Chemistry with Mr. Brazil. I'm going to show you a second stoichiometric problem, but this time it's a mix of molarity and mass, and it just throws a little bit of a curveball, but not much. And I'm trying to alleviate the fears of molarity solution. So this is the second part to the first stoichiometric problem, and I tend to do these via two-step. So let's take a look at the problem. A student experiments by adding 20 milliliters of 0.50 molar hydrochloric acid to 1.5 grams of calcium carbonate in a reaction vessel. Determine the possible amount of calcium chloride that can be produced after evaporating the water and CO2. So it looks like the student wants to isolate the calcium chloride as crystals, as solid. Also, what is the approximate amount of excess reagent that can be extracted after the reaction? What is left over in that reaction vessel that can be washed off or separated or poured off? Let's see. Okay, let's start doing a two-step method. That means I'm going to take the molarity and I'm going to convert it to calcium chloride. Calcium chloride is the product of interest. That's right here, the CaCl2. The other two have been evaporated away. So I'm going to write down 20 milliliters HCl, and I'm going to convert that to mass calcium chloride. Well, I know that the M over here is molarity, is moles over liters. So I need to convert that milliliters to liters, so ml HCl to 1 liter HCl. Now I'm in terms of liters, so liter HCl to 0.50 moles HCl. Well, since our balanced equation is in terms of moles, we can convert moles to calcium because it's 2 moles of hydrochloric acid. So let's take that 2 moles from the balanced equation. The 2 moles comes from the balanced equation. We'll require 1 mole of CaCl2. Since I could stop right here at moles and find my limiting reagent and excess reagent, but I'm going to go to mass because we want to know the amount that's left over. So let's convert this to a mass, and whatever unit's up top, let's put it on the bottom. If you notice, that's what I was doing. That came from the last video. So it's 110, and so this is rounding also 110 grams of calcium chloride. So this is going to give me a value of 0.55 grams CaCl2. Now I can't stop here. I'm going to have to run the 1.5 grams because I do not know yet which one's the limiting or excess reagent. So I'm now going to take the 1.5 grams CaC, the CaCO3 or calcium carbonate, and whatever units up top I'm going to put on the bottom, so grams CaCO3 to mole. So I'm taking the molar mass. I'm going to need the periodic table for this. Let's undo that last one. Okay, CaCO3. So that is 100 grams. Taking the periodic table, adding the calcium to the carbonate. And then again, I'm going to use the balanced equation. So 1 mole CaCO3 will produce only 1 mole CaCl2. I'm going to use the mass again. So whatever units up top, put on the bottom. Mole CaCl2 is 110 grams. So notice that I am able to repeat, but this time it's going to be a whole different value, 2.2 grams CaCl2. Well, what is this giving us? Well, if you watch my last video, you're going to see that the smallest value is our theoretical yield. So this reaction will produce an approximate amount of 0.55 grams of calcium chloride. That means that this 0.5 molar hydrochloric acid, the 20 milliliters of it, is our limiting reagent. So the 20 mils is tied to this. So the 20 mils of 0.50 molar hydrochloric acid is our limiting reagent, and this right below here is our excess reagent. So there's some of the calcium chloride in the reaction vessel, which we could just pick out, wash off, and then evaporate all the other, the water and the CO2, well, any CO2 that's trapped in the water, we could evaporate off, and we could get this chunk of calcium chloride, or calcium carbonate, excuse me, calcium carbonate. So how do we do this? Well, here's what I would do. I would take, let me use a different color here. I would take these two values and subtract them out and convert the difference to the calcium carbonate. So to do that, I'm going to do this right here in this lower left corner. I'm going to take the 2.2 grams CaCl2, the 0.55 grams CaCl2. Subtract that out. I'm going to get 1.65 grams CaCl2. Okay, that overage is due to the 1.5 grams of calcium carbonate. So let's see how much is actually used up or how much is left over in the reaction. So I go 1.65 grams CaCl2, parenthesis fraction bar. So whatever units up top, put on the bottom. So it's going to be 110. I'm going to take the molar mass, 110 grams calcium carbonate to mole calcium carbonate. So the grams are gone. Okay. So whatever units up top, put it on the bottom. Mole calcium chloride. And I'm going to convert this to, 1 mole to 1 mole. So nothing's changed from up above. So 1 mole to 1 mole calcium carbonate. And then this is gone. Whatever units up top, I'm going to put on the bottom. So mole CaClO3. And that is 100 grams. Came from the second line. Or I could recalculate, but I wouldn't do that. It's a waste of time. And so this value, once I do my calculator work, turns out to be 1.5 grams calcium carbonate. So that this carbonate, 1.5, is what's left over in the reaction vessel. It could probably be picked out, washed off, again, as I mentioned. Okay, hopefully this alleviates some fears. Just don't be afraid. Molarity is already putting this in terms of moles. All we have to do is convert the milliliters to liters. The unit moles over liter are always present in the capital M. That capital M is moles over liter, always. Okay? Enjoy chemistry. Look up stoichiometric problems with molarity and from other people. They're out there on the web. And enjoy. Bye.